Assalamu alaikum, dear friends and colleagues. We are continuing the AC Schooling Weekly Series. The next course is phase imbalance. In the previous lesson, we talked about the impact of low voltage in single phase units. In this lesson, we will discuss what happens if there is a voltage difference in three-phase systems. Ideally, the voltage of all three phases should be equal. But does a 10 to 20 volts difference matter? Let's take a look. If one phase is 380, the second is 370 volt, and the third is 360 volt, it creates negative sequence currents inside the motor. In engineering, this means the magnetic field turns into an ellipse. A magnetic braking effect is created. It is as if the motor is braking against itself while running. As a result of this resistance, the windings overheat excessively. Remember, even a 5% imbalance can increase the winding temperature by as much as 50%. This is a direct ticket to insulation failure and motor burnout. So, how do we diagnose phase imbalance? For this, we need a multimeter. Now on your screen, you see the actual procedure for measuring phase imbalance. Let's calculate. The average voltage is 407.3 volts and the maximum deviation is only 1.3 volts. This means the imbalance is only 0.3%. These readings taken while the AC is running are close to ideal and the system is in the safe zone. However, if you see a difference of more than 2% during measurement, it is a serious warning sign. Let's explain the danger threshold using the International NEMA methodology. Let's go back to our example of 380, 370, and 360 volts. First, we find the average voltage divided by 3 equals 370 volts. The maximum deviation from the average is 10 volts. Using the formula 10 divided by 370 times 100 equals 2.7%. For three-phase compressor, 2.7% is already a danger threshold. This is because a small voltage imbalance causes the current in the windings to differ by 20 to 30%. Current imbalance is always 6 to 10 times higher than voltage imbalance, which leads to rapid burnout. Now take a look at this chart. So what is the solution? First of all, you must check the electrical contacts, the condition of the contactor, load distribution, and most importantly, the phase monitoring relay. This problem can also result from uneven phase distribution within the building's infrastructure. In such cases, the local power utility should be notified. As a last resort, a three-phase stabilizer can be installed, but remember, this can be nearly and as expensive as the AC unit itself. In developed countries, voltage stability is usually high and fluctuations are rare. But we prepare these lessons for technicians all over the world so they can diagnose problems at an engineering level. Thank you for watching us until the end.